In this video, I'll show you how to program the buttons on your microbit. If you need to learn how to set up your microbit for the first time, check out the first video in this tutorial series, linked in the video description. We left off our last program with something like this, an animation inside the forever block, where we show one icon, wait for a second, show a different icon, wait for another second, and then the code repeats and goes back to the top of this loop and starts over. This program has two event blocks, onStart and forever. You can identify event blocks because they're flat at the top, so they won't snap on to the bottom of another block. These blocks tell the microbit when to do something. The onStart block only runs once when the microbit first powers on, and then the forever block repeats forever. When it reaches the end, the code goes back to the top. We can access different event blocks for the microbit's buttons from the input menu. Click on Input, and then drag out an onButtonA pressed block. I'm going to move the code for my animation from the forever block to the onButtonA pressed block. So I can just click the top block there, all of the blocks below it will follow along, and snap it into my onButtonA pressed block. The onStart and forever blocks are now empty, but that's okay. We can see that now the microbit doesn't automatically show any animation because there's no code in either one of these blocks. This code won't run until I press button A. You can do this in the browser simulator simply by clicking on the button. We'll see that it will run the animation, but only one time. Unlike the forever block, the onButtonA pressed block is not a loop. It runs the code once and then stops at the end, so it's still showing the small heart icon. If I want the screen to clear and get rid of the animation at the end, I can go back up here to the basic menu, select the clear screen block, and snap that on to the end of my code. Now, when I click the A button, the animation will only play once and then the screen will clear again. What if I want to use more than one button to do different things? Then I can add another onButton pressed block. As we saw on the previous video, you can drag another block out from the menu, or you can right-click a block and select Duplicate. If you duplicate an event block, this will also duplicate everything inside of it. However, note that this one is grayed out. I can't have two different event blocks that both tell the microbit to do something when button A is pressed. However, I can select the drop-down menu and choose between button A, button B, and buttons A and B, or what will happen if you press both buttons at the same time. I'm going to switch this one to button B. Let's say that instead of playing an animation, I just want each button to display a different icon. So I'm going to click and drag to get rid of the bottom part of the code in each event block, and again, remember you can drag it over to the trash can icon here to delete the code. I'm also going to do that for my button B event block, and then I'm going to change the two icons. For example, say I want button A to show a smiley face, and button B to show a frowny face. This could be a great way for someone who has difficulty communicating verbally to show their emotions to someone else. You can learn more about doing that from the link in the description, where we have various science projects you can do with your microbit. Now, if I click the A button, the microbit will show a smiley face, and if I click the B button, it will show the frowny face. That face will stay on screen until I click the other button. Clicking one button multiple times in a row doesn't change anything. For example, if I repeatedly click the A button, it's already showing a smiley face. Note that the microbit defines a button press as pressing and releasing a button in less than 1 second. If you watch closely, you'll see that the face does not change to a frown until after I have pressed and released the B button. If I press and hold down a button for more than 1 second before releasing it, the corresponding onButton pressed event block does not activate. If I'd like to clear the screen, I could use another onButton pressed block for buttons A and B. So I'm going to select the drop-down menu, select A and B, and change the code inside this block to clear the screen. Now, since you can't click in two places at once in the web browser, the simulator gives you this extra virtual button for A and B. But when you download this to a physical microbit, you can just use your thumbs to press both buttons at once. Now we'll see that if I click button A, it shows the smiley face icon. If I click button B, it shows the frowning icon. And if I click this virtual button to simulate clicking A and B at the same time, it will clear the screen. Here's that same code running on a physical microbit. When I press button A, it shows the smiley face. When I press button B, it shows the frowny face. And there is no third button, but when I press both buttons at the same time, it clears the screen. Remember that if you need to learn how to set up your microbit and connect the battery pack, check out the first tutorial in this series, linked in the video description. In this video, you learned how to write code that runs when a button is pressed quickly and then released. But what if I only want to do something while a button is held down? For example, showing the smiley face while I hold button A down, but clearing the screen as soon as I release button A. In the next video, we'll learn how to do that with something called an if-else statement. Make sure to check out the next video in the series to learn how. Check out the links in the video description for the rest of our microbit tutorial series and lots of fun science projects you can do with a microbit. For hundreds of other projects in all areas of science and engineering, check out our YouTube channel and be sure to subscribe so you never miss a new project. Thank you for helping us inspire the next generation of scientists and engineers.